We now move to groups. Groups are regular expressions that are associated in some way by the meta characters open and close parentheses. These are going to associate characters together as a regular expression. So for example, previously quantifiers only worked on single characters or character classes which we know are interpreted as single characters. Now they'll be used to apply to groups as well. Since character classes do represent a single character, you can't put groups in character classes. Here's an example. We have 4 strings, LD, LED, LAD, and LEAD, and we want to associate the E and the A together to test if they're there. Now, if we put them together with the open and close parentheses, we see right here and right here, that's going to associate the E and the A together so that this question mark right here, this quantifier, which says is it there or not, must apply to both of them either being there or not being there. So for example, in the first case, they're not there, and in the last case, they are there. And those are the only cases where true is returned. By contrast, if we only put the question mark on the A, it's asking L followed by an E, followed by an A or no A, followed by a D. So which ones does that match? Well, it doesn't match the first one because there's no E. It does match the second one because it's LE, no A, D. It does not match the third one because there's no E, and it does match the last one. Okay? Hopefully you can see the pattern that we're developing here. If you put the question mark on both of them, on the E and the A, now they're all true because they all have either an E, an A, or neither of the two. So the grouping effectuates both of them. They either both have to be there or neither of them are there. Alternation is a very powerful aspect of regular expressions. It's common to want to express a pattern that can look like this or this or this, okay? We've seen this with character classes, but this is going to be a little bit different. This is effectuated with the pipe operator, and the pipe operator is going to be interpreted as OR. Character classes can give you an OR for individual characters. Alternation is going to give you a kind of OR for entire regular expressions that are thought of as alternatives. Now, these regular expressions are going to extend to some boundary, right? If they're expansive past one character, you have to say, well, how far will they expand in the regular expression? And the rule is they'll either expand to the end of the regular expression or they'll extend to the end of the group. So alternation is almost always seen in combination with groups. Occasionally you'll see it without groups, but almost always you'll see it with groups. In some cases, the order of the regular expressions listed in the groups matters. So for example, here I have first name Anna, and it's piped into str extract Alice pipe Ann pipe Anna. So this is saying pull out something called Alice, called Ann, or called Anna. Now, notice in this case that Alice is first. So what's going to happen is it's going to rifle through, it sees the A here, and it says, okay, I matched that A there, I'm going to keep going. The problem is that it meets the L here of Alice, and it says that doesn't match the A here, okay? And it keeps going on. Now, what about Ann? It sees the A, it's good, the N, it's good, and the N, it's good, so it has a match. Regular expression engines are said to be eager. They want to match the very first thing they can. So here, the result is Ann and not Anna, which would be the full match. Let's see another example in terms of groups and alternatives with emails. Emails here is a character vector of 5 strings. Each of them contain emails that are intentionally obfuscated in some way. For example, in the first, we see just the simple foo@bar.com. So that's obviously an email address. But in the others, it's more complicated. Email me at foo@bar.io. That is a valid email address, but of course it's not space AT space. We need that @ symbol there. Undoubtedly, we have all seen email addresses that are like this on web pages where people are trying to hide the fact that their email address is directly listed. But is there a way that we can use our groups and alternatives to try to pull these email addresses out? And the answer, of course, is yes. So the strategy here is that we're going to build this up one by one. The first thing that we want to do is give a regular expression that represents the @ symbol. When we look at this regular expression, we have the @ symbol in the middle. It's a group, so we are actually listing alternatives, okay? So the alternative is in the middle, and then it's going to expand all the way to the end of the group. Now, I either have the @ symbol or I have A followed by T. Now that's not going to match our big AT above, so we're probably going to take everything to lowercase at the very beginning. Also, you see this space followed by the asterisk? We know that the asterisk is a quantifier which says 0 or more, and the space is just white space. We could have put tabs or new lines in there, but we just haven't done that for this particular exercise. So that's how we're going to capture the @ of the email address, which is something @ something dot something. Next, let's try to get the dot. The dot is either going to look like a period or it's going to look like DOT. So we make a regular expression exactly the same way. It's a group, there are 2 alternatives, and they may or may not have white space around them. And if they do, it could be an arbitrary amount of white space. Lastly, the domains, that's the .com or .edu, whatever. Here, this is just a series of alternatives. Again, it's a group with a whole bunch of alternatives. Lastly, the regular expression, we're going to create the regular expression using glue. Glue is really useful for that purpose, where we make little bitty regular expressions that match particular pieces of what we're looking for, and then we glue them together into one larger regular expression that we never have to actually specify in full explicitly. Here's what happens when we apply it. We'll take our emails, we'll pipe it into str to lower, which makes it a little bit easier to parse, and then we use str extract all, and notice we get a list back of all of the regular expressions that we wanted. And in fact, they're correct. So foo@bar.com, that's the easiest one. Foo@bar.io, okay, this is looking good. Foo@bar.edu, and so on. So clearly we've been successful in doing this. Now we can actually go a bit further and we can actually replace all of those regular expressions by what their canonical form is. For example, the space AT space should just be an @ symbol, and we can use str replace all with the @ regular expression followed by the @ symbol to actually effectuate that. And that's precisely what we see here. Or in dot, we have the dot right there, and now we're going to actually get all of our email addresses back, and we're getting them back formatted in a way that we can actually embed them directly into some kind of email client to send emails. Now, if we were actually doing this, the actual regular expression that matches email addresses is significantly more complicated. This is from the book R for Data Science. You can look it up there, and it goes down about 4 times further than this. So in general, the actual rules for email addresses, the actual standard, can be very complicated. Now into back referencing. Groups can actually be used for back referencing, and what that means is that you're going to match a pattern that was previously found. For example, in a text processor, you may run into this problem. I kicked the v-ball. This is very common when you're actually doing editing, where you go back and you've edited something, but you forget to remove the article or you include the article, and it ends up just being there twice. And the question is, how would you actually find all examples where that kind of thing has happened with a regular expression? The problem, of course, is that you don't know in advance what the word is that's going to be duplicated. So here's how we do this. We make a group, we say that there's some word characters in the group, and then there's a space followed by this back reference. The back reference is saying the thing that you just matched, the first group that you just matched. So here it finds THE followed by a space followed by THE. That was the regular expression that was matched in the pattern, and that's a successful use of back references. You can actually use this in a limited extent in str replace. So for example, if I wanted to actually fix that problem as opposed to just extract it, you can do that. My success has been somewhat limited in doing this with stringr, but it certainly is possible to a limited extent. Lookarounds are also really useful when you have a pattern that you want to match, but the pattern should always be preceded by something or should always be followed by something. They're always formatted like this. They look like a group followed by a question mark followed by the equal sign by whatever your regular expression is. Okay? For example, if you wanted to match a regular expression that's followed by something, but not the followed by regular expression, okay, it would look something like this. The regular expression would begin with the desired regular expression, and then it would have the open parentheses, question mark, equal sign, followed by whatever the regular expression is that should follow it, okay? Now, the match that you're going to get here is not going to include that nearby regular expression. It's only going to include the desired regular expression. We'll see an example of this in just a moment. Right now, all we need to know, it's a desired regular expression followed by some other regular expression, but you don't want to match the second one. You only want to match the first one, okay? You can do the exact same thing if you want to precede, and it looks almost identical. The difference is the parentheses question mark equals, that expression now goes before the regular expression that you want to match, and you put a less than right before the equal sign, okay? That's the only difference. So as you're thinking about this, think about it as parentheses question mark equals following it, but if you want to precede it, just move it to the front and put a less than right before the equal sign. Lastly, if you want to negate this, so if you want to say something like not followed by or not preceded by something, instead of using the equal sign, you'll use the exclamation point. So think, the bang character very often negates things, and it's going to negate it here as well. How about some examples? So I have our stereotypical pattern there on the right. Let's say that there's a salutation email that looks like Dear David Kale, okay? And I want to pull out the salutation itself, but not the comma, okay? What I do here is I have my lookaround. My lookaround is the open parentheses question mark equals. The regular expression here is very, very simple. It's just the comma. So something followed by a comma, extract that, but don't extract the comma. And that's the important point, okay? Notice that there is no comma right there. So the regular expression has done its task. Now, something a little bit more typical may be actually the other way around. Pull out everything after the deer, okay? So in this case, we have a preceding lookaround. So again, it's question mark less than equals, and of course this precedes the regular expression that we want to match, followed by essentially anything, okay? And that's why we have the whole Dear David Kale comma. Of course, in practice, we'd probably want to do both of those together. Like if we want to pull out the name is going to have some salutation, dear, or whatever, followed by a name, followed by a comma. So how would we just pull out that name, okay? And what we're going to do is we're going to use a combination of lookarounds, preceding and following, okay? So to begin with, we have the preceding one, which pulls out anything after the dear space. Then the regular expression that we want to match actually has the following one right here. So that's the question mark equals comma, and everything that we're matching is just literally everything in between, white space and all. So that's going to pull out the name itself. So again, lookarounds are always going to use two regular expressions, one that you want to match and one that you want to find, but you don't actually want to pull out. Anchors are a useful thing as well. Anchors are saying I want to match a regular expression either at the very beginning of a string or the very end. The code for the very beginning is the caret symbol. So if you have a caret followed by the regular expression, it's saying match at the very beginning of the line. So for example, when I say str detect B in A, B, C, D, E, it does find it in the first one, but it does not find it in the second one because the B is not at the beginning of the string. If you want to find it at the end is coded by the $sign. So here I check if D is in the string, the answer is yes. I check if D is at the end of the string, and the answer of course is no. The $sign is indicating the end of the string. Word boundaries are useful for regular expressions that happen either at the very beginning or the very end of a word, and it's usually used to avoid words that are embedded in other words. For example, this is a strange sentence. The Theo from Athens liked to tithe, okay? The characters THE appear several times in that phrase, but notice that they appear in different places in the words, right? In the first word, THE, it's just the entire word. In the second one, THE is the first three letters of the word. In the third one, it's embedded inside of it. And in the tithe, there, the last one, it's at the very end, okay? Is there a way that we can express that we want to find that pattern at the very beginning of a word or the very end of a word? And the answer is yes. But it's not the same as the anchors before. Remember, the anchors before was the entire string. It's matching at the beginning of the entire string. Here I'm interested actually in words themselves, and that's where word boundaries come in. To insert a word boundary, you use //b, where you want the boundary to be. So here I have //b THE. That says there's a word boundary followed by THE, and it matches the and Theo since those are the places where that occurs. Of course, I can put the //b anywhere. So I could put it at the end of the regular expression where it's THE//b. I would match the and then tithe, or I could put it on both sides where I only match THE. Lastly, just a few things about regular expressions in RStudio. Regular expressions can be used for find and replace in RStudio in a really useful way. It turns out that if you actually highlight the regex button, you can type in regular expressions into the find and replace in RStudio, which is really, really useful. And in fact, you can even back reference them to fix problems that are there. So for example, in this case, I have G followed by the assignment operator with no spaces. And I want to find that there's a function called G followed by an assignment operator followed by function. But now I want to put those spaces in. And notice what I've done is I've put in this little back reference right here, just the single /1, which is saying I want you to find that particular regular expression and embed it into whatever is being replaced. Obviously, this is successful. Lastly, regular expressions can be used for find and replaced in entire projects as well. To do these, it's Shift-Command-F, and notice that there's that regular expression box. If you check that, then whatever you type in the find box will be matched by regular expression anywhere in the project.